Hello, everyone, and welcome to today's session. Today, we are going to talk about a very interesting topic, machine learning as a service. So let's quickly get started. So before we actually dig deeper into this topic, I would like first of all to introduce myself. If you don't know me, I'm Garima Bajpai, founder for the DevOps community of practice here in Canada, which has several chapters: Toronto, Montreal, Edmonton, Atlantic provinces, Montreal. If you have not joined any of our chapters and if you're around, I highly encourage you to check out these chapters, be part of one of the chapters around you, and also see various ways how you can contribute to these communities, local communities, close to your local base, right? So now let's quickly get started. Today's topic, exploring machine learning as a service. I have taken support for this session from various sources, including a book published recently, Azure Machine Learning Engineering. And this is a publication from PACT. If you are interested to kind of get some more practical insight into how machine learning as a service works, primarily on Azure, this is the book for you. So let's quickly get started. Again, as I always do with all my sessions, I start from the overview. So let's take this as next steps. First of all, if you're interested to know more about, the ecosystem and how, machine learning is connected to DevOps and DataOps, we have done a few sessions in the past in the community. I will recommend you go check out how DataOps helps to govern the new data security strategy using hybrid cloud. There's another very, very good session by Vasu on data storytelling. Like how do you explore the potential of modern age data, and specifically how do you provide storytelling to your executives, your senior management. Um, there is another topic which we explored in our sessions, which was data ops role in SRE observability and measurement. If you're interested to dig into that topic, that also the link is there on the slide. As I mentioned, I've taken a reference book here, which is Azure Machine Learning Engineering. So if you are interested to get hold of that book, the link is there on the slide. So now let's get back to the topic, machine learning. So let's start with the basics. Let's kind of first of all understand machine learning basics. So I'll start this with like basic fundamental definitions and overview. So machine learning, deep learning, and neural networks. You might have heard about these terms, and they all are subfields of artificial intelligence. Machine learning is an important component of growing field of data science. Machine learning word itself was coined by Arthur Samuel in 1959, who was an IBM employee. The purpose of machine learning is to use machine learning algorithms to analyze data. So why do we need machine learning? First of all, scale of data. Companies are facing massive volumes and variety of data that needs to be processed. And processing power is more efficient and readily available nowadays. So these kind of algorithms and this technique of machine learning is also helpful in ecosystem and environment where we have huge amount of data to process. Unexpected findings. So since machine learning algorithms update autonomously, analytical accuracy improves with each run, and it teaches itself from the dataset it analyzes. So machine learning algorithms can uncover hidden insights without being specifically programmed to do so. So we have talked about the potential of machine learning. Let's understand some practical use cases. So recommendation engines, if you are around and you have seen like how e-commerce sites work, or how, all these, let's say, content engine works, using past consumption behavior data, AI algorithms can help to discover data trends that can be used to develop more effective cross-selling strategies. So if you are a subscriber of Netflix, Spotify, those kind of content platforms, or you are subscribed to retail platforms like Amazon or any kind of e-retail shops, you would understand the power of recommendation engines. Fraud detection. Banks and other financial institutions can use machine learning to spot suspicious transactions. Supervised machine learning can train a model using information about known fraudulent transactions. So if you are a credit card holder or a debit card holder, you must have noticed that banks have a very intelligent mechanism to kind of find and spot like an anonymous behavior and also anomalies in the system to identify any fraudulent activities happening in your account or in banks in general. Financial trading, designed to optimize stock portfolios, AI-driven high-frequency trading platforms make thousands or even millions of trades per day without human intervention. So that's one area where machine learning can contribute. Precision medicine initiatives detect subtle patterns in genetic structures and how one might respond to different medical treatments. Learning systems for automated robotics, from self-flying drones and promise of industrialized self-driving cars. All this is possible today with advancements in applied data science and machine learning. And primarily, if you look at Amazon, Facebook, Netflix, and of course Google has been using machine learning algorithms to drive searches, recommendations, target advertising, and more for well over a decade now. So how does this work? So we have different types of machine learning. Of course, different people have different views on this, but for the sake of this session, I've identified 4 types of machine learning which are primarily kind of existing in our ecosystem, starting from supervised learning. The data sets being used has been pre-labeled and classified by users to allow the algorithms to see how accurate its performance is. So supervised learning is used in number of these recommendation engines or your weather forecast reports and all those kind of things, where you already know the labels and you have classified the data. Unsupervised learning, the raw data set being used is unlabeled, and an algorithm identifies patterns and relationship with the data without help of users. Like if you have 2 pictures, one for a cat and one for a dog, and how do you identify, is it a cat or a dog? Those kind of problem statements. Now, semi-supervised learning. Semi-supervised learning is the data set contains structured and unstructured data, which guides the algorithm on its way to making independent conclusions. The combination of 2 data types in one training data sets allow machine learning algorithms to learn to label unlabeled data. And reinforcement learning is the data set uses a reward punishment system, offering feedback to the algorithms to learn from its own experiences by trial and error. There are other different types of machine learning algorithms which are being evolved or developed. This data which I have sourced is from NVIDIA, and they talk about a little more detail about these algorithms. So if you're interested to know more, you can refer to that link in that slide. Now, when we talk about machine learning algorithms, we have certain very popular algorithms which work on these types of machine learning. So let's start with some popular algorithms. Neural network, recognizing patterns, play an important role in applications, including natural language translations, image recognition, and speech recognition, etc. Linear regression, this algorithm is used to predict numerical values based on linear relationship between different values, like weather forecast or temperature sensors, those kind of things. Logistic regression. This supervised learning algorithm makes predictions to categorize response of variables such as yes or no answer to that questions. Clustering is another algorithm which is very popular, used in unsupervised learning. Clustering algorithms can identify patterns in data so that it can be grouped. So as for example, I gave cat and dog and the images of those two kind of, categorizations. The decision trees can be used for both predicting numerical values, regression, and classifying data into categories. And lastly, random forest. In random forest, the machine learning algorithm predict a value or a category by combining the results from number of decision trees. So if you want to know more about these algorithms, how are they being used in different kind of recommendation engines, or if predicting a price of a house in like 2 years, those kind of things, I think you can go and research on your own and get hold of these techniques and these patterns and types of machine learning applicable to different use cases. Now, from an evolution of machine learning, again, we have popular algorithms, we have types of machine learning, we also have tools and applications who support this machine learning at scale. But from an evolution perspective, what is happening? Of course, we are producing unexpected amount of data, right? So how do we ensure we have machine learning at scale capability? So one of the evolutionary areas is going beyond collecting and analyzing phase of big data by focusing on machine learning algorithms can be rewritten or extended to scale to like petabytes of data, or both unstructured and structured, to generate sophisticated model used for real-time predictions. So this is one of the areas of research as people are kind of also experimenting with algorithms and trying to ensure that we incorporate that scale, volume, and variety of data. The second evolutionary change which is happening from machine learning perspective is cloud data ecosystem. Gartner recommends organizations evaluate data ecosystem based on their ability to resolve distributed data challenges, as well as to access and integrate with data sources outside their immediate environment. So that has resulted into like multiple cloud providers coming together, building marketplace solutions for data and its ecosystem. There are several of these data ops companies and data frameworks, which are kind of integrated in one way or the other to establish that ecosystem for cloud data. Then automated machine learning, or we also call it AutoML. AutoML automates the process of choosing the most suitable machine learning model for a given task. AutoML tools can be automatically fine-tuned models or parameters of the model, and a process is known as hyperparameter optimization. Many of these, let's say, application and tools vendor, and of course cloud service providers like Google, Azure, they have taken a stab on AutoML capabilities through their application and tools, which they have provided and hosted on like several platforms. MLOps is also a growing area where machine learning operations are, of course, it takes the approach and the mindset from DevOps. But why do we need MLOps? Is because of the adoption of machine learning, capability into product features. When that grows beyond a definite scale, then we also need to have a method for creating, deploying, and managing these enterprise grade applications more effectively. And MLOps can play an important role in this, and it's also an evolving area. Machine learning as a service. Now, to the core of the discussion, machine learning as a service is an umbrella term for collection of various cloud-based platforms that use machine learning tools to provide solutions that can help ML teams out of the box machine learning capabilities, tools, applications AutoML features, and MLOps capability. So basically, all this evolution put together in one way, we see machine learning as a service, one of the strong potential candidates for futuristic machine learning adoption. Now, when we talk about machine learning as a service, machine learning as a service market is quite big. It is valued at $1 billion in 2019 and is expected to reach $8.48 billion by 2025. This is a research by Research and Market report, and I have also tagged a link to this slide so that if you're interested to know more about it, you can pick that report and you can also investigate further. Now, what I will do in this this part of the session, I will highlight some of the key capabilities from the CSPs, where the CSPs are providing, the cloud service providers are having platforms for machine learning as a service. So Amazon Machine Learning Services, Amazon provides a number of services, and they have a robust collection of machine learning tools through their machine learning services. And I'll talk more about those tools, applications, as well as services. And there is also an IDE, integrated developer environment, which is provided, which is Amazon SageMaker, if you have heard about that. Now, Azure also provides Azure Machine Learning Studio. It also has a range of tools for data analysis, visualization, data labeling, to deep learning. As it is a Microsoft Windows, most of the operations in Azure ML Studio can be completed using a graphical drag and drop interface. I'll talk about more of these services in the later slide. Google has a Google machine learning platform as well, Cloud AutoML, that's what it is called popularly, is fully integrated with all Google services, and it stores data in the cloud. Trained models can be deployed via REST API interface. It relies on Google's state-of-art transfer learning and neural architecture search technology. Again, if you're interested to know more about this, you can actually go into a number of areas which are like online available. Google has a very good documentation in terms of how these services are linked together and how the platform works. IBM Watson Machine Learning is another platform which I wanted to refer here. It's again machine learning as a service platform that helps data scientists and developers in accelerating their AI and machine learning deployments. Now let's go a little deeper into what are the key advantages of these kind of services. So I've picked some of these from like these service providers only. So first of all, accelerating time to value, simplifying and speeding up your workflow orchestration. You don't have to like build everything from scratch. You have available services, you can just integrate it, and the workflow orchestration is also provided. So it also simplifies in a way and also creates some perspective on time to value. Collaborating and streamlining. So supporting that end-to-end machine learning life cycle becomes easier because of one way of doing things, and also trying to standardize the tools and applications in the ecosystem. The end-to-end capability provided by those platforms as machine learning as a service is also a very handy feature. Built-in governance, security, and compliance, very important. Full source scope security, vulnerability management, and think about it. In today's time, we all tend to use open source tools. So it is also one of the benefits of having a machine learning service which can take an end-to-end accountability of governance, security, and compliance in a shared responsibility model. Responsible AI, so building explainable models using data-driven decisions. So it is not something which you're like cooked here and now. It has been tested, tried. There are multiple experiments built in by these platform owners, and these capabilities are provides a more responsible and a confident posture. when it comes to machine learning. One of the main benefits using, let's say, Azure, it has a variety of algorithms available to play with. The studio supports more than 100 methods that address classification, binary, multi-class, anomaly detection, regression, recommendation, text analysis. And we have talked about like the most popular algorithms, the most popular types of machine learning. So basically, they are implementing those kind of methods with specific use cases, learnings and all those kind of things. Now, when we talk about specifics about, let's say, machine learning services from Amazon, before going deeper into Azure, Amazon offers a robust collection of machine learning tools through its machine learning services and its Amazon SageMaker IDE. So Amazon Comprehend is used for natural language processing. Amazon Lex is for building conversational chatbots. Amazon Forecast for building time series forecasting models. Amazon Recognition for image and video analysis application. Amazon Poly for superb text to speech translation. Amazon Deep Racer, Deep Lens, and Deep Composer for deep learning services. And for data scientists, Amazon SageMaker Studio is a machine learning environment that simplifies the workflow by providing tools for quick model building and deployment. Now coming to Azure Machine Learning Services. It is a lot to learn in one session, but I will cover this part as well. And then I also refer to that book, which you can get hold of to get a step-by-step guide to using these services in Azure. So the Azure services, the platform, as a platform, it hosts a number of machine learning services, and I'll highlight some of them. Azure Machine Learning, that brings AI to everyone with an end-to-end scalable, trusted platform with experimentation and model management. Azure Databricks for fast and easy and collaborative Apache Spark-based analytic platform. Azure Open Datasets for cloud platform to host, share, and curate open datasets to accelerate the development of machine learning models. Azure Anomaly Detector to add anomaly detection capabilities to your applications. Azure Bot Services to intelligently, and this is a serverless bot service that scales on demand, and Cognitive Search for AI-powered cloud search services for mobile and web application development. There's another very interesting service, AI Gallery, which I'll talk in the later slide, is another big part of Azure ML. It's a hub of machine learning solutions and data science model templates provided by the Azure community. You can also be one of the contributors. So let's look at the key capabilities. So again, simplifying this, if you're new to Azure machine learning service, there are certain building blocks for this service, starting from infrastructure, which is optimized for Azure machine learning service itself. So Azure machine learning supports several compute options for varying machine learning workloads. Users enjoy the ability to spin up a compute instance on demand by running Jupyter Notebook or RStudio or Jupyter Lab. It also supports Databricks, HD Insight, and Azure ML clusters. Azure Machine Learning also provides data store to mount data from Azure storage service, such as a data lake store. Users can access data store from a UI or from Python code by using Workspace or a data store class. Azure Machine Learning Notebooks feature supports, as I said, Jupyter Notebooks, Jupyter Labs, and RStudio. Users can flexibly open up an existing Jupyter Notebook kernel or create a customer kernel, depending on your particular use case. The Azure Machine Learning Designer feature lets users specify and create machine learning models through an interactive GUI. Now coming to the second building block. So machine learning service provides a common workspace for all your machine learning experiments, pipeline, compute resources, datasets, environments, images, train models, endpoint, and an SDK to interact with all these resources. So Azure Machine Learning Designer, it's a no-code environment to build models for clustering, regression, classification, anomaly detection, and recommendations models, as well as data statistical and text analysis. Azure Machine Learning Pipelines, this is a workflow of executable steps in machine learning that composes of a complete like machine learning workflow. Environment, as we talked about, it's an encapsulation of the environment for your machine learning, training your machine learning models. And lastly, Auto ML. Azure Machine Learning also provide ML flow integrated into your auto machine learning capability. Now we can talk about more specific features. Let's say Azure Databricks. Azure Databricks is a unified open analytics platform for building, deploying, sharing, maintaining enterprise-grade data analytics and AI solutions at scale. Azure Databricks to accomplish tasks essentially for processing, storing, and analyzing the data that drives critical business functions and decisions. Databricks has a strong commitment to open source community, and I'm very glad to kind of bring that up. Databricks manages updates on open source integration in the Databricks runtime releases. There are many open source tools which Databricks has brought forward in the data context. So it is very interesting if you can go and check out those. Infrastructure used by Azure Databricks to deploy, configure, and manage the platform and services, and the customer-owned infrastructure managed in collaboration by Azure Databricks or your own company. Both possible solutions can be implemented through this capability in Azure. Azure Open Dataset, as we talked about earlier as well, is a platform to host data from an open domain such as weather or social economic statistics or game popularity statistics or like voter statistics, machine learning samples, open images and GitHub activity data, etc. on Azure. Open datasets also provide Azure Notebooks and Azure Databricks Notebooks you can use to connect data to Azure Machine Learning and Azure Databricks. Datasets can also be accessed through a Python SDK. Now we talk about Azure AI Gallery, which is one of the most exciting features Azure provides. It's a community-driven site for discovering and sharing solutions. The AI Gallery contains a variety of resources that can be used to develop your own analytics solution. So it has an experiments area. The gallery contains a wide range of experiments that have been developed in Azure Machine Learning Studio. Jupyter Notebooks include code, data visualization, and documentation in a single interactive canvas. Solutions where you can quickly build up like templates or reference architecture or design patterns. Projects, explore projects contributed by experienced members of the data science community. So again, it looks very exciting. Everything looks very promising, but is machine learning for everything or everyone? So let's explore that part as well. And this is a blog which I have referenced over here. The source of the blog is at the bottom of the slide, but I feel that it is very important to reflect when and when not to use machine learning. So let's start with when to use machine learning. If you are already using one of the cloud providers for your company, you have a cloud ecosystem into your like enterprise architecture, then integrating machine learning as a service can help you kind of get a good addition to your already existing cloud footprint. If many use cases can be outsourced to a predictive API, machine learning as a service is for way to go. If application generate a lot of data and you need to carry out tests frequently on that data, you definitely would try out this service. If you run a microservice-based architecture in your company, and ML as a service would help you proper management of those, some of those services. Of course, like cost management and posture correction, or even integrating AI ops into your enterprise grade capability are some of the use cases you can also look at. Now, when not to use machine learning as a service, if the data you need has to be secure and on premises, then probably it shouldn't be using machine learning as a service, or you have to have another option of a custom configuration. These custom solutions which are available, which with this standard solutions which are available in the market. If you need a ton of customization and state-of-art algorithm implementation, you probably don't need ML as a service. It could be still be useful, but again, it is useful mostly. The potential is huge when you use it for standard capabilities. If you need to optimize training or serving cost of complex algorithms, then you may want to take your infrastructure on premise. So these are kind of some of the recommendations which probably can help you decide which way to go. Now, we have shared a lot of information in today's session about machine learning as a service. I always end my sessions with something for you to think about. So if, let's say, you're a leader in this space, think about a leader's role to assess the tools and services that can help you work more effectively, and what will be the biggest advantage or sweet spot to start with ML as a service. So I leave you with that thought. And I would also introduce some more interesting books in my next session. I have a very good session lined up, an upcoming session on the modern age data and its potential. And I've taken support from Enhancing Deep Learning with Bayesian Inference and Power BI Machine Learning and OpenAI. If you're interested, these two books are published by PAC and they have been already launched. With that, I would come to an end of this session today. Thank you for being here, and I will see you next time. If you would like to see more of these sessions, please help us subscribe and share to spread the outreach of this channel. Thank you very much for your time today.